الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Assalamu alaikum, good afternoon, good evening, Masa al khair. Welcome everybody. Welcome to another session on the GGD MENA, the Digital Days. Today we're going to have another session on Google Cloud. You remember, if you attended the previous session, we had an introduction to Google Cloud. We covered quite a few things, generally the different services on GCP, the Google Cloud Platform. Today we're going to talk specifically on networking. So let's we'll see what makes Google Cloud different from other clouds, definitely from the on-prem where we do networking. And before I start, I just got a piece of news that emerged recently, maybe a week or so, and it's to do with networking with Google Cloud, obviously, and it's about a deal that Google has done with one of the major players in the industry out there, and it's about a deal that was basically done based on the power of the network on GCP, and it's based on the Elon Musk company. So 7 years contract to supply computing and networking resources to the SpaceX companies, which is the Elon Musk company, to help deliver internet services through the Starlink satellites. So the Starlink satellites internet will be relying on the backbone of the Google network, the fiber optic network, to make basically connections to the cloud services as part of that deal. So it's a major kind of deal that Google is having with one of the most innovative companies out there in Elon Musk, SpaceX. So before I go into the details and what make a company like StarX to make that decision to choose the Google network, let me tell you a little bit why the Google network is different. Let's watch this video so we'll have a better understanding of that.
At Google Fiber, our goal was to bring you the fastest internet. But we realized there was an important part of the fiber experience that we had overlooked.
Each fiber customer gets a fiber jack installed, which provides them the ultra-fast internet they enjoy. What we realized is we can take this amazing little device and turn it into so much more.
70% of users use the internet or watch their morning news with their cup of coffee. Our extensive research shows that coffee and fiber just go together.
Today, we are excited to announce a pilot of our new service offering, Coffee to the Home, your direct coffee super highway.
By adding a specialized spout to the fiber jack, we can connect it to our coffee backbone.
We tested our Coffee to the Home technology in our offices and our labs in Mountain View, California. We found that when you combine fiber optic technology with stainless steel in just the right proportions, it lets us transmit you coffee at lightning fast speeds while maintaining quality and customization.
So how does it work? It's incredibly easy. Just use your Fiber app to customize your favorite coffee brew. If you don't know what you want, the app has predictive brew technology that satisfies your coffee needs using an algorithm based on your beverage history, the time of day, and your TV viewing preferences.
Simply press the Coffee Now button on your fiber jack. The button signals to the coffee processing engine in the cloud that your order is ready to be transmitted. Then simply use the fiber spout to receive your steaming cup of joe in a matter of seconds.
Never again do you have to worry about getting your day started. With Google Fiber, you can make sure that you're always wired, in every sense of the word. We're piloting this program in Kansas City, and we'll be rolling out to additional fiber cities soon.
Thanks so much for coming over.
Thanks for having us.
I can't believe they have these.
To learn more and sign up, go to google.com/fiber/coffee.
All right, there you go. This is why Elon Musk had made that decision to have his coffee over the Google Fiber. Seriously, right? Okay. Don't go to that link. It's a joke. Okay. Let's get serious here and talk about the Google network. What makes it different? All right. So moving on. So let's talk a little bit about the traditional way to do networking. So what is a network? A network basically consists of two or more computers that are linked from different locations. They will be sharing some resources. They will be exchanging files across different mediums, whether it's telephone lines, satellites, infrared light beams, cables, you name it, Wi-Fi. So that's anything that is connected. That's what we call a network. Got different types of network: local area network, wide area networks. So this is what local area networks. Anybody at home will probably have a couple of devices that are attached to a main computer where they can be saving files or connecting printers to. And the wide area network is a connection of many of those LANs. So you can imagine talking about the cloud, you will have many of those across the globe. So it will be kind of a big task to link those. You will have a lot of devices that will help you to do those links. You will be looking about a complicated setup with bridges, routers, switches, a lot of things that needs to be done in order to provide those resources globally. And it comes with different protocols. So a protocol is just a set of rules that govern that communication between those devices, those computers, based on whatever application they are using. So this goes back to the OSA model, 7-layer model. So you can hear, for example, as an example, layer 7, all that communication happens for HTTP, SMTP. This is where that layer would be responsible for. The transport layer, as an example, layer 4, the TCP. The layer 3 would be IP communication that happens at layer 3. So I recommend you to, if you are interested in that, to understand more about networking, to look at the 7-layer OSA model. Very important from networking perspective. Networking hardware, so there's a lot to be dealt with, to be invested in. As I said, firewalls, firewall appliances, routers, bridges, repeaters. Especially when we're talking about a global network, you need a lot of repeaters in order for that signal, for the communication to happen, not suffer any kind of discrepancy in the communication that's happening, switches, and all with that. On top of that, you need to know what you're doing. So there's a lot of configuration to be done in there. There's a lot of things that needs to be configured. So you need to basically know your stuff in order to configure a LAN, let alone a WAN or a global service like what the cloud providers are doing. A topology, what is a physical topology of a network? This is basically referring to in what way I'm going to configure, I'm going to set that network. We've got different topologies. You've got linear bus, star, tree, which is expanded star. They look like this. So linear bus, so just one cable, and there will be like branches coming up from there. It is the very basic setup. It's cheap, but if the cable goes down or there's a cut in the cable, very difficult to troubleshoot where the issue is. So it's like a very basic. Then you got the star model, where you have like a switch, a connector, or a concentrator, and all your networking devices will be attached to them. It's a little bit more expensive. You need more cables, but it's like you have that hub. It's easy to detect any faults when you remove parts and things like that. And then you will have the combination of the two, a tree or expanded star, and this is when you move to more complex setups. Whichever way you're going to do your network, there is a lot to be involved in there. There's a lot to be done by hand. So it's a manual work in terms of putting those things together, configuring them from the front end, some kind of all those devices are programmable. And this is where we talk about the networking operating system. So networking operating system acts as the director. This is where I do all my policies, my rules for directing traffic from devices to each other. And then on top of that, you will have the firewall rules to basically dictate where the traffic is allowed to go, what is it not allowed to go. And you've got different kind of setups for a network. You've got peer-to-peer, where you've got those devices connected directly to each other, which is not kind of best practice, or not suitable for big organizations and things. So client server, this is the nearly the model that we see in all the companies, client server model. So it is more expensive. You will need high redundancy, high availability. So you probably need more file servers and more servers to serve those clients. In case one goes down, the other one will take over. And on top of that, so the point I want to make here, with all this hardware, with all these devices that I need to connect, there is a lot of management, a lot of maintenance that I need to take care of. In order to move to the cloud, we have what is called SDN, or software-defined networks. So in this case, what we're doing, we have an underlying infrastructure that is already set up with all those devices and things. And what I will basically be separating the control plane to create my different networks, my firewalls, my anything that is network related. It will be software defined. It will be like an interface where the user can manage those networks from the front end. They don't need to have to engage in any way, shape, or form with the underlying infrastructure for the network, whether it's cabling, whether it's the routers, whether the switches, the firewalls, whatever that might be. Everything is programmed for them, for somebody to create and leverage networking resources, networking services, just as software based. And this is what any cloud provider would do. And Google Cloud is no different. So you will find underneath the infrastructure, the fiber optic network across the globe. One of the most powerful networks in the globe, is not, if not the most powerful. I talked about this in my last session. Refer to my last session in YouTube to go to those references about the underlying hardware and the underlying fiber optic network on Google. This is what drives the Google services like YouTube and the 7 or 8 applications that are 1 billion plus users. If you go to see those references, like the Gmail, like YouTube, like the Google Photos, so all those applications are 1 billion plus users. So you can imagine what kind of infrastructure need to be supporting those kind of applications. It needs to be really powerful, reliable, available, and robust. And this is what exactly the same infrastructure, the same network that is used on GCP. So it is software defined. So when we create our virtual network, it's actually a network that is created for us as part of from the Google console. We're gonna have an example of that a little bit later as part of this. So VPC object, VPC stands for Virtual Private Cloud, referring to a network. So when I create a network in GCP, it will be a VPC. Underneath that, I will be creating my networks, I'm creating my subnetworks, and they will be in different regions in the globe. Regions and zone. Regions is a geographical area where those Google data center exist, and from Google Cloud terms, we use the term zone. So a zone is a data center where all those networking resources will be basically created, or any other resource in GCP, like the VMs and anything that comes with networking. IP addresses, virtual machines, routes, and firewalls, all those are software defined in GCP. So we can, from a click of a button, I would be able to create those. So projects and networks, they work together. So without a project, I won't be able to create my network. So a project is like the container where I create all my resources in them, including networks, including IPs, including subnetworks, including firewall rules, including routes. Anything to do with the network, I can create in a project. So this is the main thing, the main resource that I will be creating first, and then I'll create in my networks in them. Now, one of the major features of the VPC network is that I've got different types of them. So one of the most kind of powerful feature of a VPC network is that it spans the globe. So when I go to the console, I create a VPC, I've got the option to create one network that is spread all over those regions that we looked at in North America, South America, in Europe, in Asia, in Australia. So if I'm big corporation, I've got presence in all of those regions. I can create subnet in all of those regions. So I've got different options to do that. So I can create what is called the default or an auto mode network, which will create for me a subnet in all of those regions. Or I can create a custom mode network, which is more customizable, obviously. And this is what you would use for your company, because you don't want to be creating very big subnets in different regions. You would be wanting to create some custom subnets in multiple regions. Maybe you have just 5 countries that you exist on the world. You don't want those 25 regions that exist on Google Cloud. So you will be more kind of in control of that. And then you will be creating those subnets in those regions. And when you create that, you can basically create resources that can talk to each other. So one network globally that can take to each other. The traditional way to do that, you would be wanting to what you have to do is to create a network for each of those cities, and then you will be cabling and connecting them together through routing and switches and a big configuration. So it's few months work, if you ask me, if you want to do that yourself for a big company. From the cloud, this is like a 5 minutes job or in less than that. I'm creating from the software defined on Google Cloud, creating my network and be able to have that network available for me without worrying about routing and switches and configuration and things. So in 2-3 minutes time, I would be able to deploy my services globally in all the services, in all the regions. Other cloud providers also, it's not as simple as the Google Cloud. You would have to create different networks in different regions, and you will be having more tasks to be done to have the routing in place, to route traffic from one region to another. So it's a more of a complex job to do, not like GCP, not like Google Cloud. So this is an example of having in one project creating those different networks, and I can create VMs in one network. And you can see here, for example, this network is in one project, but I've got presence in US East 1 and Asia East 1. So those two machines, those two VMs, they can talk to each other directly, so they can ping each other. The only thing that I can control traffic with is firewall. So if I set up firewalls, I would say, okay, I don't want this guy here to speak to this guy, but otherwise they can talk to each other. The other two examples here, I've got two VMs in two different networks in the same region, US East 1. Now, for these guys to talk to each other, they can't talk on the private network. They can't talk with the private IPs. They need to go over the internet outside the network and then they come back in order to come back. So here is more efficient way to do this. There will be use cases where you want to do this isolation. Just be mindful that you need to go to outside in order to those machines to talk to each other. Otherwise, in GCP, there are other solutions in order for these two networks to talk to each other internally, and this is what is called like VPC peering, meaning that network they can connect to each other to talk to each other with private IPs. But there is like extra configuration that I need to do, not like this one. Those two that they need to speak into each other. One benefit I can get from that is if I'm setting up my VPN from whatever place I'm coming in. I can have one VPN gateway to talk to one of the subnets, and because of these subnets are all part of my network. As soon as I get that connectivity to one of the subnets, anything in here can talk to all those regions that are part of my network. So I don't need multiple VPNs. So that's another benefit, having this capability of VPC, the network being a global resource in Google Cloud. This is so the first one is VPC is a global resource. The second one is subnets. So the subnets, another kind of differentiator when it comes to Google Network is they span multiple zones in the region, which means that if I said the zone is a data center, a region is multiple data centers, so I can create resources, servers, VMs in the same region, in different data centers on the same subnet. And this is so powerful when it comes to things like failover. So if I got one data center that goes down, I can easily fail over that VM to another VM on the other data center, just swapping an IP address. And some services in GCP like Cloud SQL will actually do that automatically for you. So that failover is so quick that and because it's going to be the same IP serving anything that's come outside on that subnet. If you have an application talking to that backend, if you have users that are connecting to services that's provided by those VMs, they won't even notice that there is a failover or something went down. So this capability of a subnet being a regional resource that span multiple zones is so powerful. So this is like a second thing that is so powerful and super useful in GCP. Now going back to software defined. Now, I said to you, we need to create and basically use custom networks. Custom networks will allow me to start creating those subnets in different regions. And from best practices to start small, and then if I need more IPs on my subnet, I can always expand them. You can always expand the subnet, but you can't shrink it. This is a networking rule, either in cloud or even in on-premises. You won't be able to shrink a subnet. Once it's expanded, it will stay as that. The only difference that what you do this in from on-prem and cloud or Google Cloud is when you change when you expand a subnet on-prem. It's a big job. So you will need to go to all the VMs. You do reconfiguration of the subnet, of the default gateways, of the IPs, and that will require rebooting services, rebooting servers. So you need a big downtime in order to do that. Reconfiguration of firewalls, reconfiguration of switches. In GCP, it's just editing a subnet, and you're pretty much done. So you can just out of the box, you can just edit a subnet, go to the subnet, edit it, and then make it bigger. And then when you save it, that configuration will be spread to all the VMs in my subnet. So it will be just uploaded to all my VMs. And I don't need to do any configuration or reconfiguration of my VMs. I don't need to reboot them. It's another kind of powerful feature in Google Cloud. The expansion of subnets is out of the box within seconds, and I'm pretty much done. If I was on-prem, it's probably going to take you the whole weekend to do a job like that with the downtime required. And then, obviously, with that, everything is managed for me. I can have internal IPs, I can have external IPs, and with that, I will have internal DNS. So all the external IPs that are specified will be mapped to an internal IP address. The external IP address, you won't be seeing it from if you do a if config, for example, you won't be seeing that. Think of it the same as if you have your machine on from your router, connecting to your router, to your internet router at home. You won't be able to see the external IP from the operating system. You would have to go to something, what is my IP or something to see what the internet provider has given you as an IP address. This is exactly the same. So the external IP, you won't be seeing it from the internal, and this is what makes it easier to basically divide the network and expand it and send that new configuration to all the IPs without needing the operating system to be rebooted to pick up that configuration. So DNS, obviously, you will have an internal DNS for each service. This is taken care of for you. You don't have to worry about that. You can retrieve all the information about the internal DNS as well. And externally, you've got a service that is available at 100%. So actually, it's the only service that has 100% SLA. So it never goes down. It's you can use it out of the box from GCP. Is a service that is so powerful because it's global. It never goes down. So yeah, so Cloud DNS is another kind of powerful thing that is used on the Google network. So anything you can even use it on your own companies. You don't have to be using cloud in order to leverage this service, the Cloud DNS. Okay, with every VM, I can have multiple IPs as well. So I can have a secondary range of IP because I think you can have multiple IPs, so you can connect your machine to different networks as well. So let's say you are a network administrator and you have many networks you need to talk to. You can have from one machine having multiple up to 8 external IPs, external network cards, and each one will be connected to a different subnet to a different network. That's also possible. Or you can have what is called alias IP addresses. Let's say I'm dealing with many applications in my VM that runs on containers. I can set an alias IP address secondary range where each container will be associated with an alias IP address. So this virtual machine will have a role of multiple applications that I can talk to on a different IP range on different ports as well. Routes also is another configuration item that I can do on Google Cloud. It's so easy. So it's also is software defined. I can define my custom routes for my network, and this is basically the thing that I talked about earlier. When I change a configuration on the subnet, this is where it comes to the routing table. So the routing tables is unique with Google. So it's like a big router that is a virtual that is available globally, and all the configuration happens in there. So all the routes for each VM is associated with it. So if I change something, the big router will change those routes, and each VM will have its own route associated with them. So if anything changes, it will be pushed back to the VMs, and they will pick up those routes if anything is changed. So this is another route map traffic destination. So this is all based on that routing table. So each VM will have its own routing table associated with it. And it works also for VPN. So this is another visualization on how we can handle this. So you can do this. Obviously, you can control traffic from the internet. You can go ahead and configure a VPN tunnel or VPN gateways, and all this new routes that's coming from external VPN will be pushed to the individual VMs through that routing table. So each one will know that that connection will be established for each of the VMs according to those VPN gateway routing and firewall rules, if there is anything in there. Okay, firewall rules. So another thing that is so powerful and super useful in GCP. So the firewall itself is not like an appliance that I need to configure. It's also software defined. It's globally available. So I don't have a single point of failure. I don't have a point of contention. I don't have to configure a device or keep a list of firewall rules in an Excel sheet or something to know my list of firewall rules. So everything is software defined for me. So and everything, the calculation of firewall rule is done at the VM level. So so each VM will have the connection, the communication coming to it, the traffic coming to it, and then according to what rules are applied to that VM, it will check, okay, shall I allow this traffic or not? And if the rule is mapped against that VM, it's matching, then it will basically it will apply that rule, whether it's a deny or allow traffic to that VM. So this is how it looks like. So firewall rule is composed of obviously direction, whether it's inbound or outbound, ingress or egress, source and the destination, the protocol that is associated with it, the port, the action, whether it's allow or deny, priority, because the priority is if you have got two rules that are conflicting, we will be looking at the priority. You set a priority for each rule, and the rule with the highest priority will take precedence. And then the assignment. So you can assign a firewall rule to all the instances on your network, or you can assign it to a particular some of your VMs that are tagged. So you can put a tag on them. Say I want, like, I've got a front end service. I can just, when I create a VM, I said, okay, this VM tag, this firewall will be for the tags that are called front end. So if the VM is matched, it will apply that firewall rule. Oh, there is a third method. It's more granular access, more from security perspective, which is called service accounts. We'll park this one to another session to talk, when we talk in details about service accounts and how that works. Okay, this is a couple of examples for firewall use cases. This is an egress, so it means going from outside from a VM. I can apply a rule to allow traffic or deny in that case, or coming back in for an egress to specify what are the sources of IPs, ranges that are coming. I can specify where do they come from. I can specify the protocol. I can specify the port, and I permit the traffic to come in, or I can deny it. Another powerful feature on the Google network is load balancing. Another kind of software-defined capability for many kind of, I've got about six different types of load balancers, and they're divided into different areas. So I've got global load balancers like HTTP, SSL, TCP proxy, global load balancer, or I've got regional ones, which will be basically based in different regions in the region rather than globally distributed. Some of them are internal, some of them are external. So I've got a few of them here, and things that I can set up with the firewall rule is the back-end web servers or application servers that I can basically, the load balancer will load my balance, will load balance my workload coming from users globally into those instances. And this is what is called managed instance groups. Refer back to my previous sessions. I've done a demo about that, and they are based on a template. So I can scale down or scale up or scale down based on the workload that's coming on the load balancer, whether it's a load balancer load or the CPU percentage use on those VMs, or any metric that I can choose. And I can specify these templates. So if I'm scaling out, if I'm scaling more needing more VMs, automatically the load balancer will kick off the process of creating a new virtual machine for me based on this template that I specified as part of that. So this is how we, some screenshot of how to create the managed instance group. So this is the auto scaling that I talked about. Based in this case, you can do an auto scaling policy based on CPU, based on load balancing, capacity, monitoring metric, queue-based workload, whatever that might be. I can, if the load is increased, I need more VMs. If the load is decreased and hitting those thresholds that are specified for each of those metrics, I can basically give back those VMs. They will be removed from my my scaling pool, the managed instance group. So the global load balancers, the HTTP, so they're globally available. I just need an IP address, and any cast IP address, meaning that it's not a real IP address, it's just an IP address that I can direct traffic from whatever region the users are coming from to send them to the closest backend that are in that region, rather than sending them to the other side of the world. So this is like the intelligence that is integrated with the Google Cloud HTTP load balancer. I can specify the port, obviously HTTP, which will basically help me. What will that help me is to reject any other traffic. So I don't worry about any other traffic. So as long as soon as it's not HTTP or HTTPS, the load balancer would automatically reject it. Obviously, outside the load balancer, I can IPv5 and IPv4 and IPv6 clients are supported. Inside the Google network, only IPv4 is supported. I can do URL maps with the load balancers, meaning if I have different backends for different services, let's say I'm doing some kind of machine learning for to analyze videos, which means I need a backend that is so powerful on VM. So I can do, for example, a URL map like /video. Any traffic coming to that, my front end with the /video, which will be directed to the back end that serves those that purpose with those big VMs in that case. Anything else, I can do other URL maps to direct that. But usually what happens is I can do URL maps. I can do by default, if I don't have that, the other thing is happens is geographically it will be sending the users to the closest region, or if let's say a managed instance group that is down, the user will be sent to the next closest region to him that have enough resources to serve him. This is the architecture, the internal architecture of the load balancer. So you'll have a forwarding rule, you will have a target proxy and then a URL map to send to whatever backend service. There's always a health check to check your backend services and your instance group. And the health check basically will be checking on the backend servers. So if there is a failed response coming back from the backend, the load balancer automatically will stop sending traffic to that backend till it comes back, or the instance group will create another server to be reserved on the instance group that will basically get that traffic coming back. So, and the backend services also, they have their own health check, and you will have on instance group, you will have balancing mode based on CPU, based on other metrics. Like I said, you will have capacity scaler that deals with those metrics. And the resource is an example of load balancer SSL certificates. So this is another thing that Google will take care for you. So you will create your SSL certificates. They will be generated by Google for you, and there will be the termination of the session will happen at the load balancer level. So you don't have to worry about that. So from SSL certificates, security, also it's managed for you. So there's a lot to be considered here that Google will look after, and this is what makes it so powerful and makes it so different than on-prem or other cloud providers as well. Another powerful tool that works with cloud load balance is Cloud Armor. Cloud Armor is another software-defined service on GCP that will help you secure your network at the edge. So we talked about firewall rules; they're all good and powerful in terms of stopping the traffic at the VM level. But when you have traffic at the VM level, which means that if I've got a back end here, I'm having firewall rules in this area here. That means that I've already have traffic all the way inside my network. So the traffic the bad traffic that I'm wanting to stop at the VM level is already in my network. So that's not a good thing. So Cloud Armor will sit at the edge of your network before the global load balancer. So, and it will control if you want to blacklist an IP range that you don't want any traffic from this IP range. You can do that. You can whitelist your IP addresses that you want. You can even do blacklist countries, for example. So if you don't provide some services for certain countries and you don't want any traffic coming from those areas, you can block a country as a whole from hitting your Cloud Armor and hitting your network. So Cloud Armor is another powerful feature on GCP that protects you against DDoS attacks from hackers from different regions, from different IP ranges, and you can always block those. So with cloud monitoring and alerting as well, so if you have an attack from the hacker, you can basically get the IP address from the logging, and then you can say, Cloud Armor, please block this IP that is coming. This is a bad client that is coming to my network. You can always do that as well. And with cloud, the global load balancer being a global resource, that will absorb DDoS attacks. So this is very, very powerful. So I wouldn't say it's impossible, but quite impossible to do a DDoS attack on a Google network with so much power in terms of the backend infrastructure available, the fiber optic network that is globally available, and the innovation and the investment that Google has put on the layer of software-defined network that is completely secure. So this is the security policies that I was talking about Cloud Armor. You can allow addresses, you can blacklist addresses, and this is another visualization of the global load balancer. Cloud CDN is another powerful feature of on GCP. So Cloud CDN refers to caching. So So the idea behind caching is how Google they use it. They use it on YouTube. So if you look at this map here, so let's say if somebody is loading a video, uploading a video in Hong Kong, for example, somebody, let's say in Frankfurt, wants to watch that video. So the first time that a user is downloading that video to watch, he will experience some latency because he's bringing down that video across all the two continents. So he will experience buffering a little bit and latency, even though he's going through the Google network. But he will notice that. But once the video is uploaded here, it will be uploaded across all the regions across the globe in this what is called the caching, the content delivery network. So the cloud CDN. So there are CDN nodes across the globe that are available where all the caching is going to happen. So what this helps in basically latency. So anybody across the globe who wants to watch that YouTube video, they will be getting it from the CDN point that is close to them. So they would hardly notice any latencies. It will be so efficient. It will be the latency will be so low that as if he's watching it from downloaded from their laptop or machine. And Cloud CDN, the caching, what also helps is mitigate against the DDoS attacks, because if I have some content in one of those content delivery network and somebody tried to attack me because he knows the location of that, now because I'm caching everything across the globe, obviously I'm absorbing that across all the globe. So all those DDoS attacks, the connections I've tried to do, they will go all over the globe. So they won't be concentrated in one place, and they will never go back to the back end. They will be going on that in those caching locations. So I'm spreading and absorbing that attack across the globe. So Cloud CDN is another tool to mitigate against DDoS attacks as well. And this is how it works. So this is an example where somebody is caching, is sending some kind of content that is static to the load balancer. Somebody is going to the load balancer, loading that. So as long as I've got this enabled on my load balancer, it will be cached across all those regions. And then somebody is hitting the load balancer, they would be getting those whatever this guy has uploaded from their closest region. So New York user will be going to US East 1, Los Angeles will be US Central 1, somebody from Asia will go to Asia East 1. So that's the way it works. And these are kind of the network locations where GCP exists. And let me just do you a quick demo about the and then hopefully I can take some questions if there is any questions. So let me just start here. I mean, if I can stop. Okay. I'm gonna share my. Okay, I can't see any questions. Okay. Let me stop and I'll share my screen again. So I'm just gonna go to. I'll make obviously the screen bigger. It doesn't look like it's. So here I'm going to create a cloud storage bucket. Let me just log into to the console and make it bigger here. We can see what we're doing. So what I'm gonna be doing, let me see how it looks on here. I thought I was sharing, I wasn't sharing, so let me share. Okay, so this is the Google Cloud Console. I think I need to make it a little bit bigger actually. Okay, so what I'm gonna be doing, I'm just gonna start by creating a cloud storage bucket that I'm gonna be caching. I'm just gonna do simulation of basically looking at from different different regions. So if I go to cloud storage, browse, and I'm gonna create my bucket, give it a name, unique name, globally unique name. So demo. I'm gonna create. That's taken. Okay, that's fine. GDG MENA. Okay. Hopefully nobody used it. Okay, I'm gonna put in one region, and I'm gonna put it in a region that is far from me. So I'll use US East 1, which is completely another continent. I'm gonna be using it regional, so I can I don't use it multi-region because I'm that would be basically near where I am, and it will be lower latency. So as much as high latency as I can in there. So I can create that. So this is my bucket is done. I'm gonna copy some images in here, a couple of images. I'm gonna use a gsutil, which is the command for dealing with Google storage. So I'm gonna first of all create a variable with my bucket name. So I won't be typing it over and over again. So that's demo GDG. This is maybe too small here. So didn't want to do that. Let me come back here. Okay, let me make it bigger. So yeah. Text largest. Hopefully this is better. A little bit, not really. Okay, this is as much as if I can. It's the largest I can do. Okay. Right, so I created my bucket. I'm copying some files in it. I'm going to show you those files when I copy them. So let me copy that. Copy the first one, second one. And I'm going to make them public as well. So I'm going to do some gsutil IAM roles to make it public. So if I want to have a look at it here is if I go to, oops. Okay. So let me refresh. This is my bucket. So these are my files here. So I made them public. I can access them publicly. So what I'm going to do now is I'm going to create a load balancer. And the load balancer will be the back end of that load balancer is that bucket that I've created. So if I go here, let me just take that bit out here and go and make this bigger. Okay, so now I'm going to go to the load balancer. So networking services. Load balancer. Create load balancer. HTTP load balancer. I want a global load balancer to be accessed from anywhere across the globe. From internet to my VM. Okay, that's fine. I'm coming from outside. I'll give it a name. CDN load balancer. And I start doing the backend configuration. So the backend is going to be the bucket that I've created. Give it a name. GDG. Demo. Doesn't matter any name. And I'm going to specify the bucket that I've created, which my files in them, and I'm going to enable Cloud CDN. So I'm enabling the cache. I've got static content in there, and basically I'm happy to create that. And then I'm going to do my front end configuration. It's going to be okay. GDG, MENA there. HTTP protocol. IPv4 port 80, that's all fine. I'm not going to secure that. I'm going to be done with that. And then I'm going to finalize and review. And this is basically creating my CDN, my bucket, my load balancer to talk to that. So this is all software defined. If I want to be configuring a hardware load balancer, it's hours and hours in order to do stuff like this. Now with tick boxes like this, click on some clicks and I'm pretty much done. Okay, so my load balancer has been created. I click on it. So anybody hitting this IP address would be able to come to my image that I've put in there. So this is my load balancer. My image is regions.png. Obviously now it's failed because it's still basically now sending all those requests across the globe. Remember, we've got a load balancer globally. So now it's the load balancer needs time to be available from all the edge locations across the globe. So this is what's happening now. So it's taking that image and load balancing on my load across the globe. So it will take a few minutes, a couple of minutes, maybe minutes or two. So we keep refreshing. If I go back to my bucket, storage, yeah, regions.png, okay. Give it a few more seconds. In the meantime, let me see if there is any questions in the chat. Okay, can't see any questions yet. By all means, you can ask the questions in Arabic, and this is my image. If you have any question in Arabic, I can take it as well. So, ما في مشكلة إن شاء الله. اطرحوا أسئلتكم بالعربية كذلك. So here, this is my image. So this is, I came from the load balancer. I didn't access the bucket directly. So the load balancer is a public IP. Now I can access this image from there. So you can see here is, let me make it bigger. Maybe it's better here. So I took basically the image of the Google locations and I've put it in my bucket so I can access it from the load balancer. So this is in the back end of that load balancer that anybody can access it across the globe. So what I'm going to do, I'm going to do kind of, obviously, I am not all over the place. I'm only in one location. So what I'm going to do, I'm just going to simulate how this is going to be working in terms of seeing the latency. What's it going to be working from different regions. Unfortunately, I can't make that screen bigger. Let me see here if I can. Oops, completely lost it. Let me go back here. Maybe it will be better from that if I can come back to this session. Reconnect. Okay, it's better here actually. Okay, so now I'm gonna just export to create a variable for my environment variable for my IP of so I won't be basically typing it over and over again. So I can create a variable environment variable for my load balancer IP. Can put that, and I'm gonna simulate some requests, some HTTP requests through kind of a loop to request that CDN image. So I'm just gonna simulate that over kind of 9 times. So you can see here. So you can see here the first request is coming back in 0.36 seconds. Second one 0.08. So obviously the second one came from a cache location that is near where I am with the low latency. Third one coming from a further location. So these are all the where is it cache? So this is coming from the cache location. So you see different latencies here. So if let me just clear that and run this again. Oops. So if I run, notice here the latency. So I'm hitting different caching location. So probably this is the furthest from where I am. But I've got really short ones that are near where I am. So these are the. So if I go and have a look at Google Cloud locations, this would give me a good indication of where these CDN locations are. So just to give me an idea. So if I go to regions here, it's actually that same as this one. So, but I don't see the CDNs here. So the CDNs would be on this network here. So CDN points. So I am sort of somewhere around here. So the caching location that I will be hitting, let me just go down. So I would be hitting those caching locations around me. So the nearest would be those two here, and then I've got the furthest one, those two here. I can't imagine me going to caching location here. So I've got 9. So probably these are the nearest ones that I'm hitting. These are the ones that I'll be seeing here, getting that image from. So that's the ones that's there. So what I'm going to be doing next is how to I'm going to copy another image to change that. So let me replace that image. And now I'm going to do, I've copied that CDN one. So if I go to my load balancer, this is my CDN image. Let me make this smaller. Copy, let me open it in Okay, so now I want to hit the load balancer with that. I already copied the new image to my bucket, but I'm still seeing the old one because the old one is cached. So what I need to do, I need to invalidate the cache and then hit that that address again. So the way I do that, if I go to again to the load balancer, if I go to networking services, I'll go to load balancer. I'll go to my CDN load balancer. Okay, let me refresh this. Oh, I've logged out. Sorry, I need to go back to. Okay, my load balancer. Caching. And my path is cdn.png. So what I want to do with this is to invalidate the cache, because what I'm seeing here is remember I'm caching that image everywhere. I went to the bucket and I created, I've copied a new image to it, but because that image is cached across all those regions, so if somebody come into the load balancer, he's not gonna go to the bucket. He's gonna go to this cache location, and in there he's gonna see the old image, and that's why I need to invalidate the cache and then go back and see what's happening. So if I invalidate it, basically taking that image from all those cache locations. And then if I looked for that image, it will be basically going through that process, taking that image and basically caching it in those locations. So it takes a few seconds to do that. Make this bigger. So this is the load balancer. So I just went to caching and then invalidate the path where my image is. So this is a global process. So it's going all the cache locations, 100 plus is gonna basically invalidate that and empty those from that file that I cached before. Okay. So if I check, it's still working on that. So if I go to still the old image. So as soon as this process finishes, it will, I look for that image, it will bring it from the bucket, it will be caching it in all those locations again. Let me try again. Maybe it will. So as this is working, I mean, this is why I've shown you today the Google network, how it works differently because of the power of the SDN, the software defined. So Google have put this layer above the infrastructure with a lot of intelligence in it, even machine learning algorithms that work with that, a lot of innovation. So they invested billions of dollars into that network. And hopefully in the future we're gonna talk about other services in GCP, in Google Cloud, that leverage the power of that network. So Google, they've got strategic kind of ideas and strategic thinking into why they have this network so powerful. They invested a lot of money on it because all the innovation that comes on top of that take kind of advantage of these capabilities. And a lot of services they work on, they leverage the power of the network. Things like the BigQuery, things like the Hadoop managed service in GCP, which is Dataproc. So whenever we see that, they basically decouple the compute from the storage through the network, the power of that network. So here I can see that it's done. So if I go back here, if I refresh this page, and it's probably cached on mine, actually. So let me make sure that I've copied that file. And it's still looking at the old image. So let me just copy it again. So the file hasn't copied. So let me just, okay. Copy it there. Yes, you can. Okay. Okay, I know what's the problem here. Okay. Go back to that. Okay, now it's going to cache it again because it didn't copy earlier. So let me go back to the balancer. And just make sure I've got that picture in there. There. Smaller so I can see. The image is the same, that's why. It should be. This is actually the new picture. Sorry, that's the new one. So that's absolutely the new one. So this is the new one. The old one is this one. So it actually worked. Sorry. So that's the old one. This is the new one. So, apologies. Sorry, it has worked. So that's our old image, and this is our new image. Okay. Yeah. Sorry, I thought I refreshed so many times. I didn't make difference between the old image and the new image. Okay. Sorry, I took any few more minutes than 1 hour. So this is like a demo, one of capabilities of the CDN, the caching. So let me see if there is any questions. Otherwise, thank you very much for your patience, and I hope that you learned something from this today, and I hope I'm going to see you again in future sessions. Thank you so much. Thank you. Assalamu alaikum.